Just say no to the GMO. Say GMO. I just say no to the GMO. Something's fishy about this tomato. Don't you know it's a GMO?
We feel the opportunities of this technology far outweigh any perceived or actual risk.
Any politician who tells you these products are safe and that is known through scientific testing is either very, very stupid or they're lying.
GMOs continue to cause controversy, with consumer and green groups warning of unintended consequences of what they perceive to be an environmental experiment on an unprecedented scale. However, scientific communities and the biotech industry advocate GMOs as a sustainable way to feed the ever-increasing population of the planet in the 21st century. In this video, we will explore what GMOs are and the challenges faced when containing them.
Genetically modified organisms, or GMOs, can be described as a bacterium, plant or animal whose genome has been directly manipulated using biotechnology. GM technology is mainly practiced to enhance crops and animals, with further uses in scientific research. The process followed to achieve genetic modification of an organism involves the deletion, mutation or insertion of genes, and can be used to give organisms favourable traits.
Forms of genetic modification have been used for thousands of years, using the process of selective breeding, in which organisms with certain traits and therefore genes are bred to create a more desirable organism. Genetic engineering was not achieved until 1973, when Herbert Boyer and Stanley Cohen became the first scientists to directly manipulate genes to artificially create superior organisms. In 1976, the technology was commercialized and has since become widely used within food and medicine.
Despite a broad scientific consensus that food derived from GM crops poses no great risk, arguments about the safety of GMOs are widespread. Opponents of GM crops such as Greenpeace claim that there are unanswered questions regarding the long-term impact of GMO on human health and the environment. Despite these claims, the financial strength and the global influence of firms like Monsanto, the world's largest producer of GM seeds, has meant that the widespread use of GM crops has continued without setback.
Farmers have been quick in uptake of GMOs. Between 1996 and 2013, area of GM cultivated land has grown from the 6,500 to 680,000 square meters. An increase of over 100-fold, with 12% of worldwide cultured land planted with GM crops in 2010.
Microbes such as bacteria have been genetically modified to perform certain tasks, such as in the production of pharmaceutical drugs or agriculture. Despite the many benefits they bring, GMOs still carry some risk of unwanted side effects on agriculture, human health, and the environment. One other concern is the possible transfer of harmful genes used in the production of GM crops, such as resistance to antibiotics, from genes in genetically modified crops. These genes have been used in genetics for plant production and in some instances remain in the finished product. Because of this, there have been issues about the effect on human health and if these crops were able to transfer harmful microorganisms to the human body. Despite the fact that transfer of genes from parent to offspring occur naturally, there are unknown consequences to changing an organism's natural bodily function by inserting genes from other species into it. These inserted genes can change the organism's biochemistry, bodily functions, growth rate, and its response to external environmental factors. Therefore, these consequences also affect the natural environments in which those organisms live in. Potential health risks to humans include the possibility of exposure to new allergens from the affected habitat or organism. There is also a risk of horizontal gene transfer of pesticide and herbicide resistance to other organisms, which would not only be dangerous for people but also cause an ecological imbalance. Other biosafety issues include the creation of superweed, which are herbicide and pesticide resistant crops, which could consequently lead to the demise of food crops. Loss of biodiversity, increase in herbicide use to control weeds, potential allergenicity of foods, creation of dangerous novel pathogens and diseases that may escape containment. the use of GM plants may result in impacts on non-target species, contamination of organic and conventional crops through cross-fertilization or gene transfer.
This section of the video outlines some of the potential issues when GMOs are released into the environment. Since the majority of GM crops are planted in open fields, they are highly likely to come into contact with other organisms that may pollinate, eat, or live amongst the GM plants. This may lead to the number of environmental concerns. GM plants may invade and displace naturally growing plants if characteristics such as germination, root growth, means of seed dispersal, and resistance to both abiotic and biotic stress are superior in the transgenic plant. This will create an environment with a very low biodiversity, such as the one pictured, which results in the removal of the symbiotic relationship between different organisms, so other plants and animals may face loss of their habitat and food source and become endangered or extinct. A further environmental concern regarding GM release is the process of crossbreeding, also known as outcrossing. As the diagram shows, GM genes may spread to other plants, so characteristics of the GMOs may enter naturally occurring plants in the vicinity, which may give ecologically undesirable traits. For example, if pollen from a GM crop that is resistant to insects or herbicides pollinates a wild plant, that wild plant will now be able to resist herbicides and insects. This may create superweeds that may spread and overtake crop fields, as well as natural ecosystems. A further environmental concern of introducing insect toxins into the plant is that it will increase the resistance of insects to that particular toxin. Initially, insect attacks will fall, but over time the insects will evolve and develop a resistance to that toxin. Not only will it make the GM plant worthless, but it could also lead to bioaccumulation of the toxin up the food chain, which may seriously affect other organisms that eat the insect, in particularly birds. It was found that releasing transgenic Medaka fish with enhanced growth and size into a wild population could lead to the extinction of the fish within 40 generations. This comes about because female Medaka fish were more sexually attracted to larger males, resulting in the larger GM fish being more successful at mating than the wild population. However, it was also found that the offspring of the GM Medaka fish were less likely to survive into adulthood, leading to a gradual decline and eventual extinction of the species.
Looking at the food that's in the grocery store, they say it's safe, everybody eat more. On second thought, I don't really know if it's made with those GM.
Different approaches are taken by governments to assess and manage the risks associated with the use of genetic engineering technology and the development and release of genetically modified organisms. Laws and regulatory techniques have been implemented in order to prevent any dangerous GMOs impacting on humans or the environment. The regulation of GMOs differs between countries due to contrasting rules and structure of governing bodies. Regulation varies in a given country depending on the intended use of the products of genetic engineering. For example, a crop not intended for food use is generally not reviewed by authorities responsible for food safety, but those in charge of environmental safety. Within the EU, the European Union differentiates between approval for cultivation and approval for import and processing. While only a few GMOs have been approved for cultivation within the EU, a number of GMOs have been approved for import and processing. The cultivation of GMOs has triggered widespread debate about coexistence of GM and non-GM crops. Depending on the coexistence regulations of the local governing body, incentives for cultivation of GM crops differ. Regulations on GMO within the EU are regarded as the strictest in the world. All GMOs are considered as new foods and are subjected to a science-based food evaluation by the European Food Safety Authority, or EFSA. Following these tests, reports are made to the European Commission, who are responsible for creating a case for or against authorisation. Each proposal is submitted to the section on GM food and feed of the Standing Committee on the Food Chain and Animal Health. If accepted, it is either adopted by the European Commission or passed on to the Council of Agricultural Ministers. The Council has 3 months to reach a qualified majority for or against the proposal. The If no majority is reached, then the proposal is passed back to the Commission, which then adopts the proposal. Once a decision is made, the regulations are set for the whole of the EU. However, if the species is given the go-ahead, individual countries can still temporarily ban the crop and have it reviewed by the EC, should they think it dangerous to the environment or human health. Here in the UK, a number of different authorities are responsible for regulating the contained use of genetically modified organisms, and as a whole are known as the Competent Authority, or CA. In England and Wales, the Competent Authority body comprises of the Health and Safety Executive, HSE for short, and the Secretary of State, represented by officials from the Department for the Environment, Food and Rural Affairs, otherwise known as DEFRA. For Scotland, the HSE and Scottish ministers make up the Competent Authority. Across the UK, all three parties have equal and overlapping responsibilities and work together as the Joint Competent Authority. The HSE is the point of contact for inquiries, notifications and inspections regarding the Joint Competent Authority.
All activities involving genetically modified organisms or GMO in containment must use physical, chemical, or biological barriers or any combination of these to limit exposure with people and the environment, whether it's laboratory scale or factory scale. Control measures are systems and action used to minimize the risk of contact to GMO. The most efficient way of control measures must be used from the least effective in order of elimination, substitution, engineering controls, administrative control, and finally, personal protective equipment, respectively. In some cases, multiple of controls are being used at once. The controls must be used to minimize the level of exposure to the lowest level and the least to a level where it will protect human health, animals, plants, and other aspects of the environment. Local exhaust ventilation, or LEV, is equipment used to control airborne contaminants by containing and capturing solids, liquids, or gases. There are several types of LEVs such as microbiological safety cabinets, or MSC, like one in the laboratory. It is used for controlling aerosol of GMO. MSC function by using airflows to capture aerosols and trapping them in a high-efficiency particulate air filter. Personal protective equipment (PPE) is required while working with GMO. PPE need to protect the body, hands, eyes, and face, such as laboratory coats, gloves, goggles, and face shields. Respiratory protective equipment is also necessary. It only used where the control measures can be used and act as an only additional control. Simple disposal, dust masks do not prove protection against GMO. The proper inactivation and disposal of waste of GMO is a very essential part of work. Autoclaving is the must method to inactivate all GMO and contaminated waste, unless other methods are specified in the risk assessment. Autoclaving is impossible for carcinogen GMO and toxic contaminated waste. Autoclaving is the most efficient inactivation method and currently the easiest and the least time consuming for check and monitor. The condition of autoclaving is maintained at 121 degrees Celsius for at least 15 minutes with full steam penetration. In conclusion, these are only several ways to minimize the risk while handling with GMO containment. I hope you enjoy it. Thank you.
Since the commercialization of genetically modified crops in 1994, genetically modified food have been currently widely consumed all over the world, including soybeans, corn, tomatoes, and so forth. Considering the quite distinct views held by public, some of the promoters for GMOs mainly think that GMOs can largely benefit the third world countries via ability of the large-scale production and other advantages, where GMO opponents concern more about the potential long-term safety risks and other ethical issues. However, it is important to keep in mind that most citizens actually hold quite ambivalent views, which both support and criticize the development of GMOs. Some of the questions brought up by public include: why do you need GMOs? What are benefits? Who will be responsible in case of unforeseen harm? Who will they be held to account? One of the major findings from the public survey was relevance ignorance of GMOs and the DNA recombinant techniques across the public. The understanding of scientific techniques carried out by the scientists for the genetic modification of organisms are often rather limited and sometimes misconceived. Some of the people even think that only GMO fruits have genes, but regular fruits don't have genes. In addition, people often express their feelings of ignorance as due to the fact that the government or companies or any other GMO promoters did not take the trouble to explain to the public about the technology used in generating these GMOs in a way that the general public could understand. The important finding point is that principal public concerns were mostly based on their own empirical knowledge, which could be right or wrong rather than comes from the scientific laboratory or any kind of expert. Unintended effects will necessarily occur, both harmful and beneficial. This will only become apparent later, which consequences which cannot be imagined become apparent. The technology is too young, too recent, we do not have enough backside. However, we have to understand the reality that ordinary life is associated with numerous of the risks as well as the benefits, which have to be balanced against one another in ways which are often incommensurable. Many people come to complain about the missing of the proper labeling for GMO products on the market. That it would appreciate more if the regulator requests a much more clear identification for GMO versus non-GMO products so that the public can make the decisions by themselves based on the open information. Furthermore, mutual trust is based on effective communication between the social group. Thus, if the government officials can share more about the scientific examination for any of the GMO products to the public, and explain more about how they take the potential risk of the GMO products into account when they are making any decision, the public will hopefully understand more about the benefits and the risks regarding GMO products and will be able to make their own decisions more wisely.
Thank you, far too kind. Can I get an encore? Do you want more? Cook and roll with the Brooklyn boys. So for one last time, I need y'all to roll.